This is a screencast for, it would be Webassign number 1 that involves gas laws like Boyle's, Charles, and Lusak's is the first one in the gas unit. I take it back that I'm having issues. I was reading letter C. We are on letter B. So my volume equals, my volume 2 equals 2.23, and that must be liters. And that is what that answer says right there, so we are on target. Let's look at this next one, letter C. I have a volume, which those have been volume 1, and that's been pressure 1. What is the pressure? So I'm trying to find pressure 2 when the volume 2 is that. So again, we do P1 V1 as P2 V2, and my P1 in this case is 125 atmospheres, and it's asking for millimeters of mercury. I can do that. And V1 is 4.09 milliliters equals P2 times 13 milliliters. And it's good that the milliliters actually cancel out. So I go 125 times 4.09, and that is 511.25 atmospheres equals P2 times 13. Now I do the 511.25 divided by 13. So my pressure 2 equals 39.327 atmospheres. Now I have to change those to millimeters of mercury. So I'm going to go 39.327 atmospheres. And 1 atmosphere is 760 millimeters of mercury. So I just really multiply by 760. I have all those digits in my calculator, and that's a ginormous number. And you can only have 3 sig figs, so 29. I know my calculator says 888, but we have to stop here, so the 8 next to it causes it to be a 9. That's a lot of pressure. I feel like my head is swimming from that pressure. Let's move on to number 8. Number 8 says, suppose 1.29 liters of argon gas, so that's a volume. That is not the function I wanted, but it's the function I got. So we have a volume, 1.29 liters of argon is cooled from this temperature, so that must be T1 to T2. What will be the new volume of the argon sample? So if you look at your equation sheet, I usually just take the overall equation, which is this one. P1 V1 into T2 equals P2 V2 in 1 T1, and I just use the things that I have. And in this case, I don't have pressure and I don't have moles. So I'm going to cross those out, and then I'm really just going to use V1 T2 is V2 T1. Notice that the pairings are opposite numbers. So I'm guessing that's probably V1, so we'll say 1.29 liters. And we have to do times T2. This always has to be in kelvins, and it's already in kelvins, equals V2, which we don't know, times T1, which is 304 Kelvin. So we go 1.29 times 84 divided by the 304, and that does equal 0.356 liters. Moving right along in search of good times and good friends. Whew. Number 9. What is the final pressure? So final pressure would probably be P2 of 145 millimeters of mercury. That's another pressure, so that must be pressure 1 of argon gas at that temperature. That must be T1. If the gas is heated to that temperature, that's T2. Assume the volume and the amount of gas are held constant. Note the temperature must be converted to Kelvin degrees. Okay. So it looks like I have P's and T's, and I think it was P1 T1 equaled P2 T1. Sorry, P1 T2 P2. So P1 is 145 mmHgs times T2, which is 164. We have to add 273 to get in kelvins, because if you use a Celsius scale, there's a 0 on it. that is meaningful, but if you multiply by 0, you get the number 0, which is not so helpful. Pressure 2, we don't know, and T1 is 66 plus 273. And we do the math, and we get a pressure to, let's go down here, equaling 187 millimeters of mercury. So you got to add those up and add that up and then do the math. Let's move in the groove. Question number 10. What is the volume of, I need my new color. What is the volume, so we're trying to find V, of 210 milliliters, so that's probably V1, of oxygen gas at 60 degrees Celsius, so that must be T1, and 500 millimeters of mercury, that must be P1. If the conditions are adjusted to millimeters of mercury as pressure, that must be pressure 2, and that must be temperature 2. Assume the amount of gas is held constant. Hint, the temperature must be in Kelvin. So what is the volume? So we're trying to find volume 2. And we will use P1 V1 T2 equals P2 V2 T1, and now we just plug and chug. So we get our P1, which is 500 mmHgs, times our V1, which was 210 milliliters, times our T2, which is 55 plus 273. I got that from right there. Equals P2, which is 770 mmHg. That's great, our units match. Times V2, which we don't know, times T1, which is 60 plus 273. And let us see what we get here. So 55 plus 273 is 328. And over on this side, 60 plus 273 is 333. Who doesn't like that number? So now we go 500 times 210 times 328, and I hit the equals button. And we divide by 770. I hit the equals button, and I divide by 373. And I get not the answer that I was supposed to get. Let's see where we could have gone wrong. I must have just plugged it into the calculator incorrectly because I did it again, and the V2 does equal 134 milliliters. So you go 500 times 210 times 328. I hit the equals button. I divide by 770 because I got to move it to the other side, and I divide by 333 because you got to move to the other side, and then you're ending with V2, and it does end in milliliters, which is good news. Let's move on to number 11. Number 11 says, what is the pressure? So we probably need some kind of pressure here of so many milliliters. I can't read it on the screen. 315 milliliters. Let's just rewrite it there. 315 milliliters. So that's a volume of oxygen gas at 143 degrees Celsius. So that's a temperature, and that's a pressure. If the conditions are adjusted to that volume, so that must be volume 2, that must be volume 1, and 50, that must be temperature 2, that must be temperature 1. And so we must be trying to find pressure 2. Assume the amount of gas is held constant. All right, so P1 V1 T2 P2 V2 T1 is the equation we're going to use. And I'm going to just start plugging in 110 millimeters of mercury times my V1, which is 315 milliliters, times my T2, which is, I never give myself enough space, but we'll work with this, which is 58.5 plus 273 equals P2, which that's the one we're trying to find, times V2, which is 820 milliliters. They're both in milliliters, right? Yay. And times T1, which is 143, that's where I got that from, plus 273. And if we add these numbers up. Let's go 58.5 plus 273 is 331.5. And 143 plus 273 is 416. And we go 110 times 315 times 331.5. And I hit equals, and I get, oh my gosh, 114,86475, some kind of crazy units, times P2 times, let's go, this 820 times 416 is 341120. And now I do my 114,86475 divided by my 341120. And miracle of miracles, I got some miracles here. 33.7 mmHgs. I'm glad I didn't have to change to another unit because that would have made me miserable. Yay! I wish you luck, and I hope this goes well for you.